Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is 1 to 7 word ladder. So let's try to understand the problem statement, and after that we will see the approach. Okay, so see, the problem statement says that a transformation sequence from the begin word to end word using a dictionary word list in a sequence of word begin word to end word such that, see, the transformation has some constant that each adjacent pair of the word differ by only a single character, and also the I will be from 1 to k in the word list. Note that the begin word does not need to be in the word list. Okay, so you see, given two word begin word and end word and a dictionary word list, and return the number of words in the sorted transformation sequence from begin word to end word, or 0 if no such sequence exists. So basically the problem statement says that we have given two word that is begin word. So if I consider this example, then see, we have two word that is begin word is hit and another word in word that is cog, and also we have a word list that contain this much of word. Okay, so in the problem statement we have to convert this hit to cog word in minimum transformation, and the transformation says that we have at one time we have only transformed single character of the word hit. That is, if I transform the first character, then both two character are same, and if I transform the second character, then the first and third character are same, like that. Okay, and if I transform the third character, then the first two character are same. Okay, so if I consider this example, then see, the starting word is hit. So if I transform one single character from this word, then if I transform the second character, then this will be changes to HOT. Okay, because one character should be changes to, this is a valid transformation. So if I transform this thing, that is HAT, HAT is also a valid transformation because I only transform the second character. Okay, and if I transform HAX, so this is not a valid transformation because we transform two character at a single time, so we have to take care of that thing. And also that transformation should be that is present in the word list as well, because see, here I transform HIT from HOT, and also HOT is present in the word list, that is why I take HOT. Suppose if I transform HIT to HXT, so this transformation is valid, but we are not taking HXT because HXT is not present in the word list. So first condition is that we have transformed one character at a time, and also after transformation we get a string, and that string is present in this word list. Okay, so see, HIT is transformed to HOT, and after that if I transform to suppose I transform to DOT. Okay, so this is also a valid transformation, and DOT is also present in this word list. Okay, and after that if I transform to DOG, then also this is a valid transformation because this only single character transform, and also DOG is present in this word list as well. And after that we transform COG, this is the end word. So if we hit the end word, so we have to return the shortest path, that is in these cases 1 2 3 4 5. So we have to return the shortest path to conversion from a start word to the end word. Let's try to understand this problem in better way in the whiteboard. Okay, so let's see. The problem statement says that we have begin word hit and a cog, and in word that is cog, and we have a word list. So basically we have to convert this hit word to the cog word. Okay, and in between there are so many conversion from hit to cog, and that conversion string will be present in the word list. So see, if I convert hit to cog, see there is so many conversion like that. See, hit is converted to hot, because here I convert I to O, so valid convert transformation, and also hot present in the word list. And after that, if I convert dot, okay, this is also valid conversion because it is converted to D, and also this is present in the word list. And next, if I convert to LOT, this is also valid conversion transformation. And then DOG, again if I convert LOG, again if I convert COG. So this is an inward, so we get a valid transformation from HIT, that is a start word, to the inward, and the number of steps required is see 1 2 3 4 5 6 7. So this transformation requires 7 steps. So we have to return the minimum number of transformation such that we get from HIT to cog word. Okay, and one thing also notice that suppose if the inward is not, inward is cog and cog is not present in the this word list, so what happens? If I do all possible transformation from HIT to anything else, but we are not getting the inward because inward is not present in the word list, so in that cases we have to return 0. Okay, and also if and also transformation that doesn't happen, then also we have to return 0. See, one another valid transformation that HIT is converted to HOT, okay, and also converted to DOT. This is a valid transformation, also converted to DOG and also converted to COG. So this transformation take 5 steps, that is 1 2 3 4 5. So this takes 5 steps. So this is also a valid transformation, this is also a valid transformation. And if I consider some another transformation, so HIT is converted to HOT and HOT is converted to DOT and DOT is converted to DOG and DO is converted to LOG and LOG is converted to COG. This is also valid transformation, and this takes the step is equal to 6. So for all possible transformation, we have to return the minimum number of steps required to transform from a begin word to the end word. So we have to return 5 in these cases. I hope you all understand the problem statement. We will discuss that how we will approach this problem statement. Okay. So see, we have the start word is equal to hit. Okay, so hit will be transformed to HOT because HOT is only valid transformation from HIT to HOT, and that is present in the word list. And if I consider the afterword transformation HOT is transformed to DOT, okay, and also HOT is transformed to LOT because these two are valid transformation from HOT because these two words are present in the word list. Okay, and also if I consider again afterward, then LOT is converted to LOG. This is also valid transformation, and DOT is converted to DOG. This is also valid transformation, and also LOT is converted to DOT. This is also valid transformation, and LOG is also converted to DOT because only one character changes from LOG to DOG, and again DOG is converted to COG and LOG is also converted to COG. So if you notice this thing, then this is like a graph. Okay, and in the graph we have given a starting point, that is hit, and we have a destination, that is end, that is cog. Okay, so we have to find the minimum number of transformation required to convert the starting word to the end word. So this is the similar approach that we will solve using the shortest path algorithm in the graph. In the shortest path algorithm, we have given a source pointer, and we have to return the destination. So we have to find the number of steps required to reach from source to destination. So this problem is also similar to the shortest path algorithm. So in the shortest path algorithm, we use BFS approach algorithm to find the shortest path. So let's try to understand this problem in little bit depth, and we will also try run the approach of solving this problem. So till now I think you all understand that this is a graph problem. Okay, because we have node like these are the node, and these words are present in the word list also. So let's try to dry run, and after that we will see the code also for better understanding of the problem. So in sorted path algorithm, in the graph data structure, so in graph data structure we have to do BFS traversal. So in BFS we take a queue data structure, okay, queue data structure, and also take a depth variable that's count that's keep track of how many depth we have reached till now, okay, and also take the size variable that's check the how many element present at a particular size. Initially let's suppose both are 0. So in the DFS algorithm, what I will do first push the what are the element present at the begin bar. So put the heat is as the begin bar, and after that we increase the depth is equal to 1, and also the size of the queue data structure right now is also 1. The depth is 1 because we reach one position inside. That is, suppose if I consider that just like graph, then it is a heat, then heat is converted to what, hot, then we reach one depth inside. Okay, so after that we pop this heat element, pop the heat element, and do all possible transformation in the heat, like brute force, like brute approach transformation, like that. First transform the first character is h, so the value transformation of h is equal to a to z except the h, because h is already in the word that is given. So there are so many valid transformation, and also check the transformation we get after transforming the first character will be present in the word list or not. If it will be present in the word list, then push it in the queue data structure. So if I pop the heat element, then our size will now reduce to 0. Okay, so if I take the all the valid transformation of heat, so if I change the first character of the heat, then I think no one possible transformation occur, because see, it is not any word that present in the word list, because if I change the first character, then it, that is second and third character, should be same for all transformation we get from transforming the first character. So there are no valid transformation occurs. So leave this thing and again transform the second character. So second character is I, so the valid transformation is from A to Z except the I. So see whether HT character first and third exist in the word list or not. So yeah, HOTs exist. So we get a valid transformation, that is a HOT from the second character after the transformation of the second character. Okay, so we get the HOT. Okay, so we have to put it in the queue data structure HOT, and after that we will see whether if I get any other valid transformation or not. So we doesn't get any other valid transformation. So if I transform the HIT, so if I transform the third character, then we are also not get any valid transformation that are also occurred in the word list. That is the so we do that things. Okay, and after that we see if the size is equal to 0, then it will do all the iteration in the depth one, and after that again we increase the depth is equal to 2, and also the size is, again we have one size. Okay, so again we get, okay, so this is for depth 1 transformation. So this is for depth 2. Again we pop the hot, that is the top of front of the Q data structure, and also decrease the size is equal to 0. After popping we get size is equal to 0. So this is the hot. So we see all possible transformation of HOT. First we transform the zeroth character, and the transformation will be from A to Z except H, because if I take the H, then both the word will be same, so ignore the H. So if I take all the valid transformation, then we get a valid transformation that occur in the word list, so that is DOT. H is converted to D, so whatever the word we get, we push it in the Q data structure, and after that we again do all transformation, and one also we get, that is LOT, because if I transform the first character we get the LOT transformation, so push it in the Q data structure. Okay, till now we have do this thing. And if I do all the possible transformation, like after transforming the second character or the third character, we will not get any valid. See, if I do these things, before doing all this stuff, put all the word list character in the set for better execution. Okay, so if I put all the word list character in the set, so yeah, so till now we calculated for the depth 2. So this is the first depth and this is the second depth. Again we calculate the size and also increase the depth, that is depth 3. Depth 3 is now calculated, and again the size is increased to 2 because this contain two word. Again pop this dot. Okay, so after popping the dot, reduce the size is equal to 1, because now the size of the Q is equal to 1, and see all the possible transformation of DOT, and also see if I get any valid also pop these things from the set data structure. Okay, so these three, again we get dot, lot is also pop. See DOT, so there is one. Is there any valid transformation after transforming DOT? So if we transform first character, second character and third character, so we get a valid transformation, that is the DOG. After transforming T to Z, so whatever the valid transformation, put it in the data structure, and after that we didn't get anything. So after that we reduce the size equal to 0 before popping. So pop the LOT, and after that we see the valid transformation. So one valid transformation is, that is, see one another valid transformation, that is COG, because if I no, okay, so the valid transformation is LOG. So LOG is inserted it in the Q data structure. Okay, and after that we reach 0. So for depth 3 we iterate all the word, and after that we again find the size is equal to 2, and also depth is increased to 4. Okay, so for depth to first pop the front element, and after that decrease the size is equal to 1. Now the size is equal to 1, and for DOG find all the valid transformations. So valid transformation of DOG is COG. So check whether COG is present it in the set data structure or not. If present, then yeah, here COG is same as the int element. So we get the valid transformation of from HIT to COG. So we get the valid transformation, and we have to return the whatever the value in the depth. Okay, so we have to return depth plus 1, that is 5. So we get the valid conversion, and that conversion take 5 steps. So I hope you all understand. So before, one thing I have missed in between, that things that I will be discuss right now. See, before checking, before doing the BFS, put these all word it in the set data structure, and also check the end word should be equal to any other word or not, because as I have discussed that if end word is not present in the word list, then whatever the transformation you will made, we will not reach at the end character. So we have to take care of that things. So before doing this BFS, we put all the things in the set data structure. So let's see the code for better understanding of the problem. Okay, so see code. Yeah, so see, as I have discussed the previous approach, previous approach that we will take one data structure that is unordered set, and in which we calculate the in word should we present it in the word list or not. So for this, we will take is present is equal to initially false, and we iterate the word list, and for each word in the word list, we compare in word with the word present. If it is equal to 0, then is present is marked as true, and after that we insert all the character it in the push it in the set data structure. And if is present is equal to false, suppose this statement will be not true in this position, then in at that case we have to return 0, and after that we do the BFS. Okay, for BFS we take a Q data structure and take a depth variable that count that till how much we get the step, count the step. Okay, now after that push the Q data structure. Okay, push it in the begin word will be push it in the Q data structure. Okay, and after that we do the BFS traversal like that. See, in BFS we do the traversal like that. See, first take a while loop that's iterate till the queue is not empty. So this while loop will be iterate till queue is not empty. Then after that we increase the depth variable, and after that also find the size at the particular depth. Okay, because as I have discussed in the approach. Okay, so for each size we do this stuff, that changing the possible transformation and check whether this possible transformation is correct or not. If correct, then push it in the Q data structure. So for this, first find the front element, and after that pop that element. Okay, and in that case, in this region we do all the possible transformation. So take a string that is temp, and one for loop that is A to Z, because temp I, so first time I is equal to 0, so 0th position should be changed. Suppose this is a hit, then first 0 position should be changed, and compare with the current with the temp. जो current changing के बाद let's suppose AIT, we get AIT, so check hit with AIT. If we get the same, after changing all the things, again we get the hit, because if both are same, then we are not going to do anything, because hit is same as HIT. So we continue at that cases, and if we compare is equal to end, suppose in some cases cog will be found, so we get the inward. So in that cases we return the number of depth at that position, and after that we check the transform word is present it in the set data structure. If present, then push it in the queue, and after that we erase that word from the set data structure, and after that at the last we will return the 0. If we get the valid transformation with, then we will return at this position, and if the last character is last word is not present in the set, then we have to return the 0, and in any other cases we have to return 0 at the last. Okay, so hope you all understand this problem statement. This problem statement is extension of the minimum shortest algorithm in the graph data structure. So I hope you all understand problem statement, and if you try to submit this approach, then see you will get the correct result. See, it will be accepted for this test cases, that is example number 1, and if you try to submit for all the cases, then you will get the correct result. So thank you for watching the video. See you in the next video.